Hi, in this video I'm going to make a 3D scan of this aluminum bracket. It's the holder for my LiDAR scanner. It's milled from a solid aluminum block. See, just one piece. The problem is that this corner edge here is very sharp and it doesn't come with the hard case. I need to put this in a soft case and it's mounted permanently into the carbon fiber plate here, so I cannot remove it. I'm going to make a 3D print plastic to cover this bracket and make it less sharp so that I can put into my soft case. Okay, first I will make a 3D scan. I don't want to spray this one. It's not washable, so I will scan with the Raptor PRO and then I will export the point cloud into FreeCAD and design a plastic cover for this part. I will use the Raptor PRO for making this scan. I have already applied the markers in the area that is very small. I use a 6mm marker because you can't put the larger marker than the area that is given. So most of the side here is 3mm, and I put a few on the top here. So I put about 40 markers. Okay, I choose 0.2 from the resolution, and I will start with the global marker first because the object has a thin wall and I want to scan on both sides. Four markers. Okay, I will use a cross line to do the scan first, and if there is some part that require detailed scan, I will use 7 lines. I will increase the brightness because this is a black object. I increase the brightness to the maximum. For the Raptor X, you probably don't need the maximum brightness, but for the Raptor PRO, it is a bit dimmer. Because I don't put a lot of markers here, there's no space to do that. So if I use 22 lines, it will require much less of the marker. um, 0.2 millimeter. Okay, here's a point cloud, 60,000 points, and this is what I scanned with the Otter. I tried with the Otter before, but you can see that the edge here is not sharp, it's quite mushy, so I cannot use it for reversing. But the Otter can scan this part without the marker. I scan this with the medium mode and track with the texture, and Moose also can make this 3D scan. It's a bit cleaner than the Otter, but it's not as sharp as the Raptor. So for my opinion, I think that the Raptor Pro gives the best result for reversing in CAD. It's much cleaner and sharper because you're gonna need this sharp edge when you do a reverse in CAD. Okay, I will try to mesh it to around 600. How will it come out? Because I'm gonna use it for reversing and I don't need every side of surface to be scanned, just the front part. So I will export this as a point cloud. You can export either PRY or ASC format. But I like ASC format. Save it and then I can close the Creality scan. Okay, this is CloudCompare. I'm going to prepare the point cloud. I just drag and drop the ASC file. Here's our scan. You can turn on EDL. It will change the point cloud. And I'm going to change the color. I like to see the contrast. See here, if I click on the top view, it's not aligned to the XY plane. So I'm going to align this plane to the XY plane. I can do this by clicking on this icon, pick the 3 points, small triangle here. If you cannot find it here, you can go to 2, level. Choose this point first, 1, click yes, 2, and for here, 3. Okay, now here it's flat. It's flat to the XY plane. Rotate this one by using one edge of my monitor to check if I need to rotate it. I need to rotate it a bit. I'm going to rotate on the C axis, right? You can move it, rotate it using the edge of your monitor. Okay, it's quite aligned. I click on check mark. Next, you need to move this to the origin point. You see here, a shift box center. It's not in the origin point. X, Y, Z is not 0, 0, 0. So I'm gonna move it. I'm do this by click on 2, registration, move bounding box center to origin. Now it's in origin point. If you click here, see, it's in XYZ is 0, 0, 0. So when you place this into the FreeCAD, the center of this object will be exactly in the center of the y-axis, so you can mirror the feature when you model in CAD. Right, next I'm going to export this in the PRY format. Click ASCII. Okay, it's our FreeCAD. I click on parametric part. I'm going to use part design because we are going to model using sketch. So I choose part design. Next, I'm going to import the point cloud. Okay, the point cloud is here, but you can see that the color that we choose, the bright green color is not green anymore. So I'm going to click on the point cloud, click on the color and change it to bright green color here. I changed the point size to 1 because it's too big. We have a very nice thin wall. Our 20 microns, you see this line, that line is 20 microns from the Raptor Pro. So it's very thin. When it's thin, it means that you can trace with a high accuracy. Okay, next I'm going to create a sketch on the XY plane. Okay, now first sketch, but our workpiece too high from the XY plane. So I'm gonna close this for now. I turn on the origin point. Click on the left side. So I'm going to move the point cloud down to this plane, the XY plane here. What I do is I click on the point cloud, right click on placement. Now I'm going to move it down, let's say -20. Yeah, this line is the XY plane. 21.3, too much, 0.2, 0.15. Okay, 0.15 is perfect. You can see here it's perfect aligned. Click on apply, click OK. Now our point cloud exactly on the XY plane. Double click on the sketch that we just made. Okay, I want to protect this edge here, which is very sharp edge. We'll create a rectangle. I will make the cap from here to here, right? And I think I'm gonna choose the size. Let me put it close, a little bit bigger. And this size also a little bit bigger. This is the marker. Then remove all the marker. Hit D for dimension. It's about 60.36. I would say 60.4. So I have a clear lens for 0.2 millimeter for one side. To make it in the center, I'm gonna dimension this to this edge. We have 60.4. Half of that will be 30.2. But you can see here, side is wider than this side, so I need to move the point cloud along the x-axis. I close this one, click on point cloud placement, move along x-axis, and that's 0.1. Yeah, I think 0.1 will be the center because left and right gap is about the same. Click on apply. Okay, so now we have a point cloud in the center, so we can mirror the sketch. Click on here for the size. I say 75 will be enough. Okay, 75. Next, I'm going to offset this sketch with the intersection. So I need sharp edge. I'm gonna offset it to 3 millimeter. This will be the thickness of the cap. So I will delete this one. We don't need this anymore. And I will extend the edge of this line. Extend the edge of this line. Gonna delete this one, so I want to keep a 75 millimeter, and I want to trim this edge, trim this edge. Okay, finish the sketch. Okay, next I'm going to extrude the sketch 2 millimeter, a thin part, this is the top cover. Click on OK. Next I'm going to fillet this edge because it has a curve, and this edge also. I think this corner is 3 millimeter. Usually it looks like 3 millimeter. So the thickness of the wall is 3. So the fillet radius should be 6. Click on OK. Now I have the top part. Next I'm going to extrude the wall. I do this by creating the sketch on this plane. I click on this plane. I'm going to create a sketch. Okay, now sketch is here. Next, I'm going to project the line from the edge here using this command. And then I'm going to, one more here. I'm going to create a sketch. And arc. Create an arc. And create a line. Final one. Okay, it's snapped to the edge. I'm going to offset this for intersect for 3 millimeter. And I will erase the outer line. Okay, and I need to add more line here. Close the profiles. I click on close. Let's turn off this. Okay, look like I have a closed profiles. If you don't have a closed profiles, you cannot extrude, right? Let's turn this back on, and then I click on the sketch. Then I will extrude this. Let's try reverse. It's a bug with a FreeCAD for extruding display. Okay, I think it's 5 millimeter is enough. Next, I'm gonna create a clip to clip it onto this part of the aluminum. I do this by creating a sketch here. Next, I'm going to project the edge here, right? And this edge, okay? And I'm going to create a box in this location, right? This box will be, let's say 6 millimeter long. It's just a clip. And I will mirror this one to the other side as well. I select this one, click on mirror, click on axis because our part is symmetry. Next I'm going to click on close, click on extrude. Okay, now it's extruded. I want it to be just above this wall. Let's try 3 millimeter. A bit too tall. 2 millimeter, too short. 2.5. Let's do this from this view. You can see 2.5 is about right. Let's try 2.5, 2.6. 2.6 would be better. It doesn't have to be that fit, right? 2.6. Okay, I keep 2.6. Okay, next I'm going to make a small triangular clips that extend into the aluminum part. What I do is I create a sketch on this plane. So I choose to draw on this side. I'm going to create a sketch. I need to project the line, this line. Okay, now it's projected. First line and second line will be like this. It's a clip. I go like less than half about this, and then I go here about 0.4, 0.8. 0.4 is too thin, right? It's a vertical line. Go here, from here to here, and then I will trim it. This tools trim. Oh, sorry. Trim. Okay. I put the angular 150 degrees. This should be able to print. I think it's too tall, right? This is too tall. Gonna change the height of the pad. Change it back to 2.5. Okay, now it's shorter. Let's go back to our sketch. Okay, now it's closer. 2.5 is closer. 0.8. So it's extend inside about 0.8. Okay, now I'm going to mirror this sketch to the other side as well. I do this by clicking here, click on mirror, click on the axis. Now it's on this side as well. Okay, close. Next, I'm going to extrude. Click on reverse. It's 6mm. What part is 6mm? So now we have a clip, 6mm. Click on OK. Now our clip is done. So next, I'm going to create. Oh wow, it's bright. Let's change the color to something dark. Okay, much better. Okay, I'm going to create a profile fit into this hole. I'm going to create a sketch on this plane. I make in a 3-point arc. 1, 2, 3. This line is not so clear. I think it's horizontal. 1, 2, 3. Okay. Next line here. 2, 3. Okay. 1, 2, 3. Okay, done. I'm gonna do it one more here in this part. Quite mushy. What about this one? Same. Right, doesn't matter. I think it will fit. 1, 2, 3. I think it's like this. Arc. 1, 2, 3. I'm gonna give it a tangent. 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 Okay, let's move it. Okay, I think it's about this vertical line. About this. And then I will trim it. Okay, next I'm going to offset this line. Minus 0.1. Okay, I will delete the original line. I think they have a function to delete the original line. Click here. Here, delete original geometry. Minus 0.1. Okay, that's quite nice, right? I will mirror this to sketch to the other side using a mirror command. Click on the axis, close. Now let's turn off the point cloud. I'm going to extrude this one. I need to turn on the point cloud for reference. I think about 3mm. Yeah, 3mm is nice. Click on OK. Let's chamfer this edge because I'm gonna print with this one face up. So I chamfer this edge 1, 2, 3, 4, 5. Right, 5 edges here with the 1.5mm. Okay, now this time the chamfer works well. Okay, let's chamfer this one too. It's sharp. I don't want to cut anything. Chamfer 1, 2. This one I go 2mm. Click on OK. Now it's done. Let's wheel with the perspective wheel. Transparent 50%. Okay, now we have our bracket cover design. And I will export this into STL files for printing. Click on the part and click on Files, Export, STL, click save. Now it's done. Alright, this one, I flip it up and slice it. I print with the ABS because that's all filament that I have. 20 minutes of printing. Okay, now I create my own caps for protecting the sharp edge of the aluminum bracket that cut my soft case. Okay, I send it for printing. It's still hot. Usually I use the fan to cool it. Air cool is faster. If I leave it to cool down in the printer, it takes a long time. Let's test fitting it. Okay, let's check the printing. Small clips here. It's print fine. And okay, it's good printing. Okay, let's try to fit this into here. Just like that. Quite good fitting. 0.1 millimeter clearance. Let's try remove it. Okay, removing is easy. Fitting is easy. Okay, no more sharp edge. So next I need to remove the sticker. Okay, thank you guys for watching. I'll see you in the next video.